You required a server rack last week in order to perform advanced AI reasoning and vision. Today, a rebel with 7 billion parameters still teaches models 10 times larger on a gaming rig. Xiaomi has finally figured it out. VL7B MIMO sees every pixel, reads every line, thinks aloud, and doesn't follow the outdated size guidelines. This is the crazy tale of that upset. Imagine a vision language model as a brain that can read texts, watch videos, and look at pictures, and then discuss all of it in a single cohesive stream. The majority of systems capable of doing this are very large, with at least 30 to 70 billion parameters. Similar functionality has been crammed into 7 billion parameters by Xiaomi, requiring significantly less hardware to operate or optimize. The first headline is modest but powerful. Three main components make up MIMO VL7B, which continuously transfers data back and forth. A vision transformer comes first. Simply said, a transformer is a sophisticated neural network layer that perceives visuals at the same resolution as what you might see on a high-quality monitor, so details never get blurred away before the model thinks about them. Second is a tiny slab of code called a projector. Its only job is to translate what the vision side spits out into a language the text side understands. Last is the MIMO7B language backbone, the bit that writes sentences and explains itself step by step. The language backbone has been tuned from the start to do reasoning, not just quick replies, so it is comfortable spilling thousands of words if you let it. Now Xiaomi didn't wake up one morning, flip a switch, and get a supermodel. They trained MIMO VL7B in 4 long phases, burning through 2.4 trillion, that's trillion with a T, pieces of data called tokens. A token can be a word, part of a word, a pixel chunk, or a piece of code. Phase 1 is basically kindergarten. The vision and language parts are frozen. The projector is the new kid, and it looks at 300 billion image caption pairs until it learns that a visual blob of orange with a green stalk lines up with the word carrot. Only after that warm-up do they unfreeze the vision piece in Phase 2, toss in 167 billion lines of mixed web pages, textbooks, and PDF snippets, and let both sides learn how pictures and sentences coexist. Phase 3 is where things get wild. They feed in 1.4 trillion tokens that cover almost everything you can photograph or write about. Street signs captured in shaky phone shots, diagrams from physics books, screenshots of phone apps, even short video clips with captions tied to exact timestamps. While that's happening, they keep sequence length, the model's memory buffer, at 8,000 tokens, which is already generous. But in Phase 4, they crank that buffer up to 32,000 tokens. At that point, the model can read an entire college textbook chapter, stare at a high-resolution photo, and still have memory left to produce explanations that run on for pages. During that last phase, they also flood the training mix with synthetic reasoning data, problems that require multi-step logic, each written out with a chain of thought, so the model learns to reason explicitly rather than guess. All this data wasn't scraped blindly. Xiaomi filtered it with perceptual hashes, so the training set wouldn't secretly overlap test sets. They recaptured images using a specialist captioner to improve grammar and context. They filtered interleaved image text pairs by knowledge density, basically keeping the useful stuff, tossing the fluff. For OCR, they added images where text is blurry, handwritten, or half-covered, so the model learns resilience. They recaptioned videos scene by scene, each with exact start and end times. And because many apps in China use Chinese interfaces, they built an engine to synthesize screenshots in Chinese, preventing the model from freezing when it sees a Hansi button. By the end of those 4 phases, we get MIMO VL7 BSFT, the supervised fine-tuned checkpoint. But Xiaomi wasn't done. They pushed the model through another gauntlet called Mixed on Policy Reinforcement Learning, NMORL, which sounds like pure jargon. But here's the idea. They let the model answer new questions, then scored those answers in 2 ways. Some tasks have answers you can check with a rule or a calculator. If the model predicts a bounding box, the system measures how well that box overlaps the right object. If it solves an algebra problem, a script plugs the final number into Math Verify and gives a thumbs up or down. Those are verifiable rewards. Other tasks are open-ended, like giving helpful instructions without being rude or biased. For those, Xiaomi trained separate reward models. one that reads text only, another that accepts images, on thousands of human-ranked answers, so the model learns what people prefer. Crucially, the reinforcement loop is on policy. That means each time the model writes an answer, the training code instantly measures reward and updates the model using that fresh experience instead of mixing it into a big replay buffer. Xiaomi wrapped every reward function behind a tiny web service, so response to reward latency is a blink. They also normalize rewards to a 0 to 1 range and scale gradients by answer length, so the model can't cheat by writing essays when a single number is enough. This final training step produces MIML-VL7BRL, and the improvement is clear. On the massive mixed subject benchmark MMU, the supervised version scores 64.6%. After reinforcement, learning that climbs to 66.7. On CharXI, a document plus chart benchmark, it jumps from 54 plus to 56.5, blowing past much larger open models by double digits. Its counting accuracy climbs from 87 to 90 plus. It even handles the vision language models, our blind trap set, images that try to trick models, at nearly 80%, which is solid. Video understanding is strong too. The model scores over 67 on video MME without subtitles and 50 MOU on charades STA, where you have to mark start and end times of an action in a clip. On text-only math, it looks almost cocky. 95.4 on Math 550 plus on the latest AAME competition questions, numbers many STEM students would envy. Where this model truly shocks is in multimodal reasoning. Olympiad Bench is full of exam-style science problems. MIML-VL7B hits 59.4. On map versus diagram heavy slice, it posts 71.5. Those scores match or beat QIN 2.5, VL72B, and QVQ72B preview, both 10 times larger. Xiaomi's 7 billion model now snaps at the heels of closed systems, like GPT 4.0 and Gemini Pro. Practical utility is also important. The GUI capabilities of MIMO will be evident to anyone developing an agent that navigates across web pages. Models are asked by Visual Web Bench to find information inside complete web pages. Xiaomi opened an online store page, asked the model in plain language to pick the Xiaomi SU7. With a custom paint job and specific interior, then add it to the wish list. MIMO parsed the screenshot, clicked the right color swatch, scrolled, selected trim, pressed the wishlist icon, and finally produced a JSON action trace that an automation controller could run without edits. That's the promise of high-quality grounding plus reasoning rolled into a single 7 billion parameter brain. So this model essentially proves three things. 1. Curation matters. Mixing reasoning heavy. Data later in pre-train keeps squeezing gains instead of plateauing. 2. On-policy reinforcement remains stable on small models and keeps improving deep into the sample count. 3. You can push perception, grounding, and reasoning forward together if you juggle the reward signals carefully. Put bluntly, the gap between hobbyist-size open models and top proprietary stacks is closing faster than almost anyone predicted a year ago. Okay, what are your thoughts? Will the need for large AI stacks be eliminated by tiny, nimble models like this one? If you enjoy this type of stuff, leave a comment below and don't forget to subscribe and like. I appreciate you watching, and I hope to see you in the future one.